Okay, now I'll continue from here. I'll continue this part. We are interested in this. Now, sir, like what is the use of this? The amplitude is going to vary. No, definitely the amplitude varies means the variation, sir, what is the frequency at which amplitude is varying? I'm interested in this one. So in place of A of t, what shall I write? 2a cos. Then amplitude. So now there's a sound wave, no? So the more POTs, what for, like, they will be given for intensity of a sound wave. So if you know amplitude, how to calculate intensity? We know intensity is directly proportional to square of amplitude. So therefore, the intensity is equal to, we'll square it. Then this will become, this will be I of t actually. 4a square cos square cos square, what you can write, 1 plus cos 2 pi f1 minus f2 t. This is the flower bracket, all divided by 2, no? It is. Now 2a square is what I'll get it. Okay, this is the expression for intensity as a function of time. So I'm interested in for when the intensity will be maximum because I'm interested to plot this graph intensity as a function of time. Let me see that how that variation will take place. How that variation in fact will occur. Okay, got this one. So for when the intensity will be maximum, for I of t, for intensity to be maximum, I want the instance of time at which it will be maximum. For it to be maximum, this quantity cos 2 pi f1 minus f2 t, or this quantity should be equal to what? Should be equal to plus 1. This one. So for this to be equal to plus 1, what should be the bracket term? 2 pi. What should be equal to? Shall we write 2n pi? All of you, you know trigonometry. I'm taking help of that one. So finally, I'll get t is equal to n into f1 minus f2. What are these? These are the time interval between two successive maxima. So what are the values of n? 1, 2, 3, 4, and so on. So this will be 1 by f1 minus f2, 2 by these are the time intervals between two successive maxima. So what shall I call? These are the instants of time at which intensity is maxima. So what is 1 by f1 minus f2? Instants of time. So what is f1, f2? Difference in signal frequencies. Instants of time at which intensity is maximum. Similarly, I want the instants of time at which the instance of time at which intensity will be minimum. Similarly, what shall I do? For I of t to be Okay, we have enough space here, no? Phi I of t to be minimum, cos of should be equal to -1. So then what for what values it will be negative? Anybody? So it should be equal to, shall I put 2n minus 1 pi? For these instants, so the pi will get, so this t is equal to 2n minus 1 n equal to 1, 2, 3, 4, and so on. So the instants of these are the t minima, I'll write it. Now what are the minima's value? So it will be 1 by I and so on. All these are in seconds. So what is this t minimum? Instants of time at which intensity is. Okay, some important data is what now we gathered. So let me do one thing, that f1 minus f2, let it be equal to 1, f1 equal to 1 to us, and let f2 equal to 1 us. So why you are doing, okay, I can assume any value. Let me choose one. Let here only. So we'll put it here. So why you are choosing, it can be anything. Just for our simplification purpose, okay, we are going to check this one. F1 equal to 2 hours, F2 equal to 1 hours. Or you can do one thing, 3 hours, and you can take this to be, we'll take like this, so that you'll notice that. What is the difference in signal frequencies? 3 minus 1, 2 hours. Okay, shall we get that instants of time? So that we'll understand. So 3 minus 1, how much it will be? 2. So this will become 0.5 second first. Then 3 minus 1, 2, 1 second. Next, what you get? 1.5. Okay, these are the instants of time. It will be, the intensity will be maxima. Okay. Next again, what are the instants of time at which intensity will be minima? 0.25 seconds. F1 is 2 hours. F1 is 3 hours. F2 is 1 hour. So 2, 1 by 4. So this will be, I think, okay, I can write it only in this way. 1 by 4 seconds, 3 by 4 seconds. This will be, and what about this? This in fact will be 1 by 2, 1 second, 3 by 2, 2 second. Either way. So it'll be easy for us. So like this, what happens? The intensity is in fact not a constant, is varying with the time. You can see at these instances maxima, at these instance minima. So in between what happens, it will have some value. It will be varying. So now what we are in a better position where the intensity is going to vary with the time. Let's plot that graph. What to plot? I to take help of this equation. This is the thing. The intensity is in fact varying with the time. Let's plot this graph. And we know F1 minus F2 is equal to how much? 2 words. F1 is 3 and F2. What are the instants of time? And I'm going to put it t equal to 0. Even n equal to 0 also will come. No, I didn't. I missed it. This one. 0 also will come. Because n equal to start from 0 like that. Okay, let's plot the graph. Okay, how to plot this particular graph? Okay, already we know the cos function. Already we have information of cos function. No? Okay, let's start the and this will be very, very useful graph for you. So the overall idea, intensity cannot be negative. I think everyone knows intensity should not be negative. So what are the frequency what we have to Earths? To Earths is what we have, no? So what shall we do now? So what is the half time period it is coming? So we'll take the 1 by 8, 2 by 8, 3 by 8. Yeah. And then I had to take the instance, no? Rough graph. What are the instants of time? 1 by 8, 2 by 8. 2 by 8 will become 1 by 4. 3 by 8. 4 by 8 will be 1 by 2. Then 5 by 8. 6 by 8 will be 3 by 2. 6 by 8. 3 by 4, no? 3 by 4. 7 by 8. 8 by 8 will be 1. 9 by 8. 10 by 8 will be 5 by 4. 11 by 8. 12 by 8 will be 3 by 2. 14 by 8. Anybody? 14 by 8. 7 by 4. Everything is t is in seconds. You can pick up any instance. So what is the maximum possible? First t equal to 0. Start here. This is time t equal to 0. All of you, you know very good mathematics. Take help of that. The physics is over. It's all about we are taking help of maths. Put t equal to 0 here. And I'll put some other color. Where you have to substitute the values of t in this equation. Now look at this. Put t equal to 0. 0 into any this quantity will be 0. Cos 0 will be 1. 1 plus 1, 2. So maximum intensity how much will be? 4a square. So this will be a square, 2a square, 3a square, 4a square. Or will a square, 2a square, 3a square. This is what? The intensity. Huh? Versus time graph. So the first point, where do it will come? It will be here. Huh? T equal to 0. T equal to 1 by 8. Substitute here 1 by 8. So or say like, sir, like we are not understanding what you have to do. So we know F1 minus F2 is how much? 2, no? So the expression for this will be, somewhere I should write it, no? I don't have place. I'll do one thing. I'll push it this down. Okay, so some of you are asking, sir, what is that? From looking at which equation you are plotting it, let me write that equation. Huh? It will help you. This is the thing. This is the intensity. Okay, now, so what is the graph? For this, you have to plot it. Let me write this. So this will become 2a square 1 plus cos. What is f1 minus f2? Will be 2, no? So this everything will become 4 pi t. All of you? I'm asking you to look at this equation. Put t equal to, put that time and get the points and join and produce a smooth curve. You know how to plot graph and get a smooth curve. Okay, let's locate the points. So first t equal to 0, it will be 4a square. Next, what will be t equal to 1 by 8. When you put t equal to 1 by 8, what is the point we'll get? T equal to 1 by 8. T equal to 1 by 8, this will be cos pi by 2. Cos pi by 2 will be 0. So 2a square. So the next point is what will be available here. Put t equal to 1 by 4. If you put t equal to 1 by 4, cos pi will be minus 1. 1 minus 1 will be 0. Will be 0. Getting some method? Okay, now put t equal to 3 by 8. 3 pi by 4. Cos 3 pi by 4. Or cos 3 pi by 2. Again, it will be, this quantity will be 0. So 2a square equal to 1 by 2. Then it will be 4a square. So this will be. So I think I do get. Okay, let me join that curve. How the curve will be? It says sinusoidal. Don't put straight line. What is this? There's the intensity versus time graph. The peaks one will indicate like this, where it is peak. Tell me, like, the person standing at point P, what will say that? The intensity is varying with time. Are you getting this one? That was the discussion what we made, no? The intensity, what happened, will in fact will vary with the time. And this is what, shall we say, one cycle? Are you getting? This is what, shall we say, one cycle? That's the one simplest thing. One intensity cycle. The first cycle, next second cycle. Or should we also call this as like a beat period? The time interval, time taken for the intensity variation to complete one cycle. So that I'll call as beat period. So what is a beat period? We should define. This is called as a beat period. Time taken by intensity variation to complete one cycle. This is called like a beat period. Will I agree this one? So this is what the, so don't take, this is the curve. This is the part. Okay, I'll do one thing. I'll shade it. So this is the curve which we should bother. This is what one cycle, huh? that will get repeated again and again. The reciprocal of beat period will become beat frequency. Okay, now this is about intensity versus time graph. Sir, can you plot amplitude versus time graph? So what is amplitude? Okay, this is the amplitude. Okay, how the amplitude versus time graph will be. Okay, we'll plot that also. We'll get exact picture. Let me compare both.